Hi everyone, I am Ananthi, working as an associate professor in PhD of Engineering and Technology. In this section, we are going to see about Fourier series by using the reduction formula. In our previous section, we just see our numerical methods, matrices and so on. Now, I am very much interested to discuss with you about the different types of Fourier series, different intervals, and we are going to see in this section. Yes, we just go to our section. What are the topics I am just going to cover in this section are Fourier series are 0 to 2 pi, 0 to 2l, minus l to plus l and minus l to plus l. Mainly I am focusing on 0 to 2 pi and minus l to plus l, which will be same for 0 to 2l and minus l to plus l. Okay. Next, before entering into the Fourier series, we just know the sum of formulas, little formulas. First one is periodic function. This is your definition. A function is said to have a period if f of x plus t is equal to f of x, where t is a positive constant and the least value t greater than 0 is nothing but the period of that given function f of x. First, we have to know the function is periodic or not. In order to that, we just know the periodic function definition. This is our definition. If f of x plus t is same as f of x, then t is equal to period. For an example, the period of sin x and cos x, that is in positive integer, is nothing but 2 pi by n. For any constant function, the period is nothing but a positive number. Next, definition. Limit of a function. A function f of x is said to be a limit if to each epsilon greater than 0 there exists a positive number delta such that modulus of f of x minus l should be less than epsilon and 0 should be 0 less than modulus of x minus a less than delta. Limit of a function is denoted by limit x tends to a f of x is equal to l. It means the limit of the function f of x at a is nothing but l. Next definition is continuous function. A function f of x is said to be continuous at x is equal to a and given epsilon greater than 0, however it may be small, we can find a number delta greater than 0 such that modulus of f of x minus f of a should be less than epsilon. And the continuous function definition is denoted by limit x tends to a f of x is equal to f of a. That is, if limit exists, then limit x tends to a minus f of x and limit x tends to a plus 0 f of x exist, and both are equal. If limit exists means both these are equal. A function f of x is said to be continuous in interval a comma b if it is continuous at every point of the interval. Whenever a function is continuous within a and b, in the sense within a and b at every point the function is said to be continuous. Next, enter into our section, Fourier series. For Fourier series, we are going to take about we have to know that some basic definition of periodic, continuous and so on, so that one limit. For that only I just give the definition as an introduction. Enter into our section, Fourier series. Our main concept is Fourier series. If f of x is periodic function and it satisfies distinct condition, then it can be represented by an infinite series. F of x is equal to a0 by 2, a1 cos x plus a2 cos bx, a3 cos 3x plus etc. plus an into cos nx plus b1 sin x plus b2 sin 2x plus etc. up to bn sin nx. On combining these summations a's and b's, we just combine it, right? We can return as f of x is equal to a0 by 2 plus summation an cos nx plus summation bn sin nx, where a0, an, bn are nothing but a Fourier coefficients. Distinct condition. If the function is periodic and it satisfies distinct condition, means what are the distinct conditions? It's for just 3 conditions. Suppose that our f of x is defined and single valued except possible at a finite number of points. Is the first point. This is a single valued point. Okay. Second one, f of x is periodic with a period 2 pi. Third point, both f of x and f dash of x are piecewise continuous. Okay, these are the three conditions. Then the above series can converge to first point is f of x if x is a point of continuity. If our x is a point of continuity, then it is converges to f of x. If x is a point of discontinuity, then it is converges to f of x plus a plus f of x minus a by 2. These three conditions are sufficient but not necessary. That is, if the conditions are satisfied, then the convergence is guaranteed. Okay, this condition is said to be a Dirichlet condition. Next, Fourier coefficients. How we can determine our Fourier coefficients? Okay, general Fourier series in the interval of c to c plus 2 pi. If our x lies between c and c plus 2 pi is given by f of x is equal to a naught by 2 plus n equal to 1 to infinity a n cos n x plus b n sin n x, where a naught equal to 1 by pi integral c to c plus 2 pi f of x dx and a n equal to 1 by pi integral c to c plus 2 pi f of x cos n x dx. Coefficient for a naught value is this thing. We have to determine the value by using this formula. Similarly for a n equal to 1 by pi integral c to c plus 2 pi f of x cos n x and bn is equal to 1 by pi integral c to c plus 2 pi f of x into sin n x dx. The values a naught, a n, b n are known as Euler's formula. We can determine the coefficients by using these formulas. First one, by putting c equal to 0, then the interval becomes 0 to 2 pi. In that case, our a naught, a n, b n reduces to f of x dx, f of x cos n x, f of x sin n x, integral 0 to 2 pi. Suppose our c tends to minus pi, then the interval becomes minus pi to plus pi and the formula reduces to a naught equal to 1 by pi integral minus pi to plus pi f of x dx and a n b n like this. By putting c equal to 0, the interval becomes 0 to 2 pi. And by putting c equal to minus pi, our interval becomes minus pi to plus pi f of x. Minus pi to plus pi f of x cos n x. That's all. Next thing, notes. Some of the important notes which we are going to use in the problems. Cos n pi. Cos n pi takes the value as minus 1 to the power n, whereas sin n pi takes the value for 0. Which implies for odd number, the cos n pi value takes as negative minus 1. For even number of pi, the cos n pi takes the value as positive plus 1. Minus 1 power 2 plus 1. So that's why cos of even multiple of pi gives plus 1. Cos of odd number multiple of pi gives minus 1. In case of sine, it takes a value of 0. This is our Bernoulli formula. Second one, Bernoulli formula. Integral u dv is nothing but uv minus u dash v1 plus u double dash v2 minus etc. and so on. We have to find up to our limits. This is our integration formula. Integral e power ax into sin bx. Combined in the sense, we are going to use this thing. E power ax by a square plus b square, a sin bx minus b cos bx. Same way, instead of sin bx, cos bx in the sense, e power ax by a square plus b square, replace sin by cos. A cos bx plus b sin bx. Okay, next thing, change of intervals. For that intervals c to c plus 2 pi, we just calculated for 0 to 2 pi and minus pi to plus pi. In the same way, for the interval of c to c plus 2l, the Fourier series is given by f of x is equal to a0 by 2 plus summation 1 to infinity an cos n by x by L summation bn sin n by x by L. And whereas in pi we just use as cos n by x. Here n by x by L. Similarly, if we put our c as a 0, then the interval becomes 0 to 2l. In that case, our a0 value is given by 1 by L, 0 to 2l f of x. an is nothing but 1 by L, 0 to 2l f of x cos n by x by L into dx. Same way for our bn. Suppose our c takes the value of minus L, then our interval becomes minus L to plus L. In that case, we have minus L to plus L f of x, minus L to plus L f of x cos n by x by L, 1 by L, minus L to plus L f of x into sin n by x by L. These are the two intervals. Okay. Then next thing, if our function f of x is an even function, then we have only two needs, a0 and an. Whereas a0 takes the value of 2 by L 0 to L f of x dx, 2 by L 0 to L f of x cos n by x by L dx. In that case, our bn takes the value of 0. Suppose our f of x is an odd function, then we take a0 equal to 0, an equal to 0. It will take only for bn. For even case, we have to calculate a0 and an. For odd case, we have to calculate only bn alone. 2 by n interval 0 to L f of x into sin n by x by L into dx. This is our formula. Yes, we are comparing. For 0 to 2 pi and for 0 to 2l. For 0 to 2 pi, we are having our Fourier series as a0 by 2 an cos nx, bn sin nx. For 0 to 2l, we have a0 by 2, same, whereas an into here cos nx, here we are having cos n by x by L, sin n by x by L. These are the formulas for our coefficients a0, an and bn, and for here to a0, an and bn. Yes. First, we move on to the problems. We mainly focus on the problems on 0 to 2 pi and 0 to 2l. Okay. And also by reduction. We are going to see. Question number 1. Express the function f of x equal to pi minus x the whole square in the interval of 0 to 2 pi as a Fourier series. Hence, prove that the sum of the series is this much thing. We are going to prove this. Okay. This is a Fourier series of type 1, which means of that interval 0 to 2 pi. So, first we have to find the series and then we have to reduce this function. Okay, first move on to the Fourier series function, whereas Fourier series f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx, 1 to infinity bn into sin nx. First calculate our a0, an and bn. First thing, a0. a0, the formula for a0 is 1 by pi integral 0 to 2 pi f of x dx. Okay, 1 by pi interval 0 to 2 pi. Substitute our function value. Here the given question is pi minus x the whole square. So, put instead of f of x, pi minus x the whole square into dx. Next, our aim is to integrate this function pi minus x the whole square with respect to x and to apply the limits. Okay, pi minus x the whole square. On integrating this, we just get pi minus x the whole power 3 by minus 3 by using the formula of integral of x power n is equal to x power n plus 1 by n plus 1. Same formula. Here it is 2, but in integration the power should raise to 1. So 2 plus 1, which takes the value of 3 by n plus 1, that is our 3. Next we have to differentiate the given inner function. So pi integrate differentiate from 0 and minus x. On differentiating x, we just get an answer of 1. So minus 1. So that only on integrating pi minus x the whole square, we just get an answer as pi minus x the whole power 3 by minus 3. We are using the formula of integral x power n is equal to x power n plus 1 by n plus 1 by using that formula. And then limits 0 to 2 pi. Next, we have to substitute our limit. Upper limit minus lower limit. So 1 by pi, we have to substitute our upper limit. Instead of x, we have to put 2 pi. So pi minus 2 pi whole cube minus lower limit. Instead of x, put a 0. So pi minus 0 the whole cube by minus 3, which is nothing but 1 by pi of. On solving this, pi minus 2 pi is nothing but minus pi. So minus pi cube minus pi cube by minus 3. Minus pi cube on combinedly adding, we just get minus 2 pi cube by minus 3. On cancelling the minus terms and cancelling the pi term, we just get 2 pi square by 2, which is our A0. In calculating our A0, we just using a single formula, nothing but integral of x bar n. Next, we have to calculate an and bn. First, an. Integral of an. Find the value of an. An is nothing but 1 by pi 0 to 2 pi f of x into cos nx dx. This is our formula. We have to replace our f of x by the given function. Here, the given function is nothing but pi minus x the whole square. So, replacing our f of x by the given function and cos nx dx. Here, integral of two functions, which is nothing but our Bernoulli formula. What's our Bernoulli formula? Integral u dv. Integral u dv is nothing but the answer is uv minus u dash v1 plus u double dash v2, etc. So, we have to choose our pi minus x the whole square as u and cos nx. Integral of cos nx is nothing but our dv. So, by differentiating u's and by integrating these, on combinedly joining these and substituting the value in Bernoulli formula, we can find integral value. For that reason, just take it u alone, pi minus x the whole square. This is named as u. We have to differentiate. Okay. First derivative, which is named u dash. U dash is equal to, on differentiating this by using the formula of x bar n is equal to n into x bar n minus 1. In that way, we are just putting our power in front of the function. So, 2 into pi minus x the whole power 2 minus 1, which is nothing but 1. So, now need to put 1. On solving this, we just get into pi. On differentiating pi, it takes 0. On differentiating minus x, minus 1. So, 2 into pi minus x into minus 1 on combinedly we just written as minus 2 into pi minus x. This ordinary differentiation of x bar n formula. Next, second derivative. U dash we completed. Next, u double dash. U double dash is equal to minus 2 into, on differentiating this, differentiation of constant 0 minus x differentiate from 1. So, minus 1 into minus 2, which is nothing but u double dash is equal to 2. So, we just calculated u dash, u double dash. And then, if we differentiate once again, u triple dash means we just take value of 0. Because on differentiating the constant, we get an answer as 0. So, it's enough if we stop it by u double dash alone. Next, integral dv. By taking dv as cos nx dx, find first v. dv is cos nx, then v is nothing but on integrating this, we just get a v answer. So, cos nx, integrating sin nx by n formula. On integrating cos x, we just get sin x. Here it is nothing but cos nx. So, we get an answer as sin nx by n. Next, our v1. Next again we have to integrate our v1. v1 is nothing but on integrating sin, we just get an answer of a minus cos. So, minus cos nx by n. Already we are having 1n. Now we are obtaining 1n. So, on combiningly, we just get answer as n square. Next, second. Once again we have to integrate this thing. On integrating v1, we just get v2, which is nothing but minus. On integrating cos, we just get sin nx by n, already n square. So, on joining sin nx by n cube. So, we just obtain value for u, u dash, u double dash, v, v1, v2. Okay, now we are going to substitute these things in our Bernoulli formula. We just move on, which is nothing but on integrating this, which is equal to 1 by pi constant, keep it as an alone in the place itself, then put a square bracket. We are going to substitute first u into v. Substitute u value pi minus x the whole square into v. V value is nothing but sin nx by n. So put sin nx by n. The limits is nothing but 0 to 2 pi. Minus is came from the formula. Next we have to substitute u dash into v1, which is nothing but our u dash. U dash we have calculated. Just to substitute the value in the relevant places. So minus 2 into pi minus x into v1. v1 is nothing but minus cos nx by n square. Substitute. Put upper minus lower limit again. Next plus u double dash v2. u double dash is nothing but 2. v2 is nothing but minus sin nx by n cube. Okay. This is just we have substituted our u v value, u dash v1 value, u double dash v2 values. Now we have to solve these things. That is nothing but minus 1 by pi, that is equal to 1 by pi. We know that on substituting for sine value, we just get, on substituting n equal to 2 pi, sine takes the answer of 0. On substituting 0 for x, we just get an answer of 0. So the first term on substituting upper limit or lower limit, we obtain a value as 0. So omit it. Same thing. Last one. Here too they are having sine. For sine function, if we substitute our 2 pi or our 0, it takes the value of 0 alone. So no need to calculate the first and the last term. Both takes a value of 0. So we are focusing on the middle one. So minus. On substituting this, 2 into pi minus x into minus plus into minus. That thing we are putting our sign. First check it for plus or minus, then numerical value, then the function. So here minus into minus plus into minus. So I am taking minus commonly as an outside. Then the remaining 2 into pi minus x cos nx by n square, 0 to 2 pi. In which there by n square, no, this n square is written as a constant term. So we are taking outside. And we return it as minus 1 by n square pi, then the remaining term. Now we are going to apply our limit, upper limit minus lower limit, which is nothing but on substituting replace x by upper limit 2 pi into cos n 2n pi minus lower limit 2 into pi minus 0 cos n into 0, which is nothing but cos 0. We know cos of even multiple of pi takes the value as plus 1. So put a plus 1. Cos 0 plus 1. And solving this, pi minus 2 pi takes the value of minus pi. On combine this thing, we just get minus pi into 2, minus 2 pi into 1. Minus 2 into pi into 1. On solving this, we just get minus 2 pi on adding minus 4 pi. Next, here too we are having pi. On cancelling the pi, we just get 4 by n square alone. This is our value for our an. These are the needed formulas. We know sin 0, 0 and cos 2n pi takes the value of plus 1. This one only we are applying here. Okay. Next, in the same way, we are going to calculate our bn. Bn, formula for bn is nothing but 1 by pi integral 0 to 2 pi f of x into sin nx dx. This is our bn formula. On substituting our function f of x, we just replace instead of f of x, pi minus x the whole square into sin nx dx. Okay. Same thing here. We are going to use our Bernoulli formula. What is our Bernoulli formula? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. So we have to choose what's our u and what's our v. So take our u as pi minus x the whole square. On differentiating u, on integrating v, and we substituting on Bernoulli formula, we can find a value for bn. Okay, move on to u. U takes the value of pi minus x the whole square. On differentiating this, u dash is equal to x power n. On differentiating x power n into x power n minus 1, which is nothing but minus 2 into pi minus x. Same cases, same answer as previous. U dash, u double dash. Okay, same thing. Next, dv. In an, our dv is nothing but cos nx. In bn, our dv is nothing but sin nx dx. Okay. On integrating integral dv, we just get an answer for v. So v is equal to, on integrating cos, we get an answer of minus cos nx by n. Okay, minus cos. If it was on sin x, we just get minus cos x. Here we are having cos nx. So we have to differentiate this thing. We have to integrate. By integrating this, the denominator should contain that coefficient of x n. So we have v is equal to minus cos nx by n. And then again, once again integrating, we obtain a value for v1. v1 takes minus sin nx by n square. By integrating cos, we again get sin nx by n. Already we are having n in the denominator. On combining, we get minus sin nx by n square. Similarly, v square. Once again, we have to integrate this thing up to u double dash. So we have to find up to v2. So v2 is equal to cos nx by n cube. And we have know the value of, in sin takes the value as 0 for 0 or n pi or 2n pi. Sin takes the value, whatever our n pi, it may be an odd or even function, sin takes the value as 0. For cos 0 equal to 1, and for cos n pi, for n we have minus 1 per n. If n takes even, it takes 1. If n takes odd, it takes minus 1. These only we are going to apply here. Okay, now apply in our Bernoulli formula, yes, which is nothing but 1 by pi u into v. First formula uv. Substitute u value and substitute v value. Minus. It's from our formula minus. Next we have to substitute u dash and v1. U dash. U dash takes the value of minus 2 pi minus x u dash into v1. Next plus, so plus u double dash v2. Substitute our u double dash value and v2 value. Next we have to solve. Here see, here we are having cos value. So cos 2 pi, it takes some value. Cos 0, it should have some value. Whereas sin takes 2 pi means 0 and 0 means 0. So no need to calculate the middle term. We can eliminate it. So on solving the first and the last term, we have answer. Just consider first value and the last value. In first value, just first put a sign, then function. So here plus into minus. So take the sign outside, then the remaining thing, in which we are going to apply our upper limit. Replace our x by 2 pi. So 1 by pi minus, replacing x by 2 pi. So pi minus 2 pi the whole square into cos n into replace x by 2 pi by n. Then upper limit we substituted minus lower limit. Lower limit is nothing but 0. Going to put our x as 0. So pi minus 0 the whole square into cos n into 0 by n. Which and the second term. In the second term, same thing as upper limit minus lower limit. Replace our x by 2 pi minus x by 0. This thing. Next 1 by pi. On solving this thing, 1 by pi minus 2 pi square, which is nothing but pi square. Minus pi the whole square. On squaring the minus term, we just get a pi square. And cos 2n pi, it takes the value as 1. So on substituting this value as a 1 by n. Next second term. Minus pi minus 0 means pi square. Cos n into 0 is nothing but cos 0. Cos 0 takes the value as plus 1. So 1 into, the remaining is nothing but 1 by n. So nothing but 1 by n. Plus 2 into cos 2n pi takes the value of 1. Cos 0 takes the value of 1 by n cube. 1 minus 1 is nothing but 0. 0 to anything 0. So last term deleted. Next this thing. Pi pi square by n minus pi square by n, which should also be deleted. So 0, 0. On multiplying 1 by pi to 0, we get an answer as Bn as 0. So in this way, we calculate the value for A0, An and Bn. On finding those values, then we have to substitute those things in our equation 1, which is nothing but in Fourier series. So f of x is equal to A0 by 2, that's the formula. In that formula, go and substitute our A0 value, An value and the Bn value. F of x is nothing but the given function, so pi minus x the whole square. A0 value by 2. A0, what we have find in A0? Our A0 value is nothing but 2 pi square by 3. We are substituting here by 2 pi square by 3 divided by 2. 2 and 2 getting cancelled. So the remaining A0 by 2 takes the value as pi square by 3. Plus substitute An value 4 by n square. Substitute our Bn value, whereas Bn takes the value as 0. So no need to put the last. So this is our equation number 1. Okay. Then we have to reduce the Fourier series to the summation, to the expression. So first we have to watch the expression. What's our expression? It takes the value of 1 plus 1 by 2 etc. So each and everything takes the value of plus. Everything should be in plus. So it doesn't contain any trigonometric functions. It means it doesn't take any cos value. But our Fourier series has the value of pi and as well as cos function. So in order to eliminate our cos function, trigonometric function, we have to substitute something for x. This we have to calculate whether the given series or in all the terms taking plus value or alternate sign. As it takes all are positive, we replace our x by 0. Suppose if it takes a value of a plus and minus, alternate sign in the sense, we take the value as pi. Okay, this is another case. Here it's all are positive, so I am taking x equal to 0. Substitute x equal to 0 in equation 1. On substituting x equal to 0, the equation will reduces to pi minus 0 the whole square equal to pi square by 3 plus summation n equal to 1 to infinity 4 by n square cos, we are putting 0, so which is nothing but 0, cos 0. We know the value of cos 0 is nothing but 1. So pi minus 0 the whole square takes pi square. Pi square by 3, on crossing the equal to, it becomes minus pi square by 3, which is equal to this thing. So we give, on solving pi square minus pi square by 3 by taking LCM, 1 minus 1 by 3, it takes 2 by 3. So 2 by 3 times of pi square is equal to summation 1 to infinity 4 by m square. Here the 4 is also again a constant. So take its common outside, taking 4 outside and by crossing that 4 to the opposite side, we have 2 pi square by 3 4 is 12 is equal to 1 by m square. On cancelling 2 and 4, we just get an answer as pi square by 6 is nothing but 1 to infinity 1 by m square. On substituting our n for from 1 to infinity, we have 1 plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus etc. This is our right hand side. This is our left hand side. What we have to deduce in the sense, we have to deduce this thing only. Find the Fourier series and hence deduce that. This is our answer and this one we have to prove the answer also. Hence the result. So in order as our function contains all the terms are positive, we are substituting our x as 0. In the same way, if it has a minus values, alternate sign value in the sense, we have to take our x as pi. In that case, we just get an answer as pi square by 12. This is your exercise. Just check it out. Find the value of 1 minus 1, 2 square, 1 by 3 square, etc. You have to deduce this thing from the given function, from the same question. It's your part. Just do it and find the answer. Okay. Next. Question number 2. In our first question, we just calculated for 0 to 2 pi, that interval. For second question, we are moving to the second interval, 0 to 2l. Same thing as pi. Okay, what we have to do? Find the Fourier series expansion of L minus x the whole square. There pi minus x the whole square, here L minus x the whole square, and find the sum of the series, this thing, and we are going to find the sum. Okay, we are to find the sum by using production formula. First, write down the Fourier series expansion. F of x is a naught by 2, a n cos n pi x by L, b n sin n pi x by L. This is our Fourier series expansion, where a naught takes the value by using the formula 1 by L 0 to 2L f of x dx. Find a naught, a n, b n, and by substituting, then we have to find the sum. Okay. First a naught. A naught is equal to 1 by pi. Integral 0 to 2L. Substitute our f of x, L minus x the whole square into dx. Next, on integrating L minus x the whole square, we are using the same formula like in our 0 to 2 pi. We know the formula of x power n. Integral x power n is nothing but x power n plus 1 by n plus 1. Here it's going in that p. By using that formula, we are having L minus x the whole power 3 divided by minus 3. We have to substitute the limit 0 to 2L. Okay, then 1 by L, upper limit to 2L, lower limit 0. On solving this, we just get an answer as, on solving the upper limit minus lower limit, we get the answer as 1 by L minus 2L cube by minus 3. On cancelling our L and minus, we get an answer of a naught as 2L square by 3. Next, we have to find the value of an. Yes, this is our formula for an. An is nothing but 1 by L integral 0 to 2L f of x into cos n pi x by L into dx. This is formula to calculate our an. We have to replace the f of x as the given function. In this question, we are having the function as L minus x the whole square. So integral of this thing into cos n pi x by L. This will looks like a Bernoulli formula. What's our Bernoulli formula? Integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus etc. So we have to choose this thing as a u and the remaining this thing as our v. So first thing u is equal to L minus x the whole square. So u dash means we are going to differentiate our u and we are going to integrate our v. On differentiating this thing by using the formula of x power n is equal to x power n plus n into x power n minus 1. We are differentiating our x power n. So on differentiating, we get 2 into L minus x the whole power 1. And we have to differentiate the inner terms, it will give minus 1. So on combining, we write our u dash as minus 2 into L minus x. Next, once again we have to differentiate. Until we get 0, we have to differentiate. So u double dash. Minus 2 into minus 1, nothing but 2. Same way, we are choosing our integral dv. What's our dv? dv is nothing but cos n pi x by L here. So find the value of our v, find v1, v2. Cos n pi x by L. On integrating cos x, we just get an answer as sin x. On integrating cos mx, we get an answer of sin mx by m. What's our m? The coefficient of x is taken as an m. So here we have L into m is nothing but n pi x by L. So sin n pi x by L divided by n pi x by L. The denominator again having a fraction. So in order to bring it as a single fraction, we just take the denominator into the numerators by interchanging. So we just get L by n pi into sin n by x by L. This is our v. Once again integrate v. We just get an answer for v1. v1 is nothing but already we are having L by n pi. On integrating sin mx, we just get an answer of minus cos mx by m. So we have minus L by n pi the whole square into cos n pi x by L. Again integrating minus L by n pi the whole cube sin n pi x by n. This is our integrating terms. We are going to substitute our u values and v values in the Bernoulli formula. See here 1 by L integral, here it is 1 by L, by mistake I have taken as a fine, 1 by L, substitute u v value minus u dash value v1 value plus u double dash value v2 value. On solving the values for upper and lower limit, before solving just to go through it, just to find, see your first term and the last term having sign. For sin theta we are having 2l, means we are going to replace our x by 2l. It will take sin something of n, sorry, something of pi, whatever the n may be. N takes the value of 2 or anything. Sin pi takes the value of 0, so no need to solve the first term, as our sin value of L and 0 takes 0, omit our first term. Similarly, just leave our last term also. Here last term also containing sin term. Of sin of L and sin of 0, both are having 0, so no need to solve our first term and the last term, so it takes only our middle term. Okay. By multiplying, first we have to write it as a symbol, minus minus minus, so minus into minus plus, plus into minus minus, so takes off minus 1 by L. Then on solving this thing, L by n pi the whole square into 2 into L minus x into this thing. We have to substitute our limit for x 2L to 0. Upper limit is 2L and our lower limit is 0. So minus 1 by L into this thing. On squaring L by n pi, we have L square by n square pi square. On substituting our 2L, 2 into L minus 2L cos n pi into 2L by L upper limit minus lower limit. We are substituting our x by 2L and x by 0. On solving this, we get L minus 2L is nothing but minus L. Minus L into 2 minus 2L. Here minus 2L. On solving this, minus 4L. So minus into minus plus 4L square by n square pi square. This is our AN value. So what we have done in our AN? Just integral u v dx, which is nothing but we are using our Bernoulli formula to find the value of AN by using the formula of integral of x power n, differentiation of x power n. This thing only we are using here. On substituting these formulas, and we find the value of AN as 4L square by n square pi square. Same way we are going to calculate our Bn. For Bn, this is our formula. What is our Fourier series Bn formula? 1 by pi, 1 by L, integral 0 to 2L, f of x into sin n pi x by L into dx. We are going to find this thing to substitute our f of x by given function L minus x the whole square. Next, what is our Bernoulli formula? uv, u dash, v1, u double dash, v2, etc. Same way, find our u, find our dv. Differentiate our u's, integrate our v's, and substitute the value in our Bernoulli formula u into v minus u dash into v1 plus u double dash into v2. On solving this, we need to solve only first and the last term because it contains cos value. Our middle term contains sin value. We know sin takes the value of 0 for 0 and for all pi. So no need to find the value for the middle term. Leave that middle one, find the value for first and the last one. On finding the value by substituting upper limit minus lower limit, we just get an answer as, on substituting upper minus lower and solving, answer as 0. For Bn, we get an answer 0. In this sum, we calculated A0, An and Bn. Next, we have to substitute these things in Fourier series. Substitute in the Fourier series. Substitute our A0 value. A0 is nothing but 2L square by 3. We just calculated. By 2. So that 2 and numerator 2 getting cancelled. Finally, we gave an answer as a L square by 3. Plus summation n equal to 1 to infinity. On substituting An value, this thing. For Bn, it takes the value of 0. So no need to put a Bn values. This one is alone. If they are asking the question to find the Fourier series alone, this is enough. Just put f of x here and This question contains a second part of find the summation of. In order to find the summation, we are just going the reduction. We have to see the summation. The summation value means summation 1 to infinity 1 by n square. It all contains positive. So, we no need of trigonometric function and we need of plus alone. So, what we have to put? We have to calculate that thing. So, by putting x equal to 0 alone, we just get an expression of right side this thing. So, find the value. By putting x equal to 0 in equation 1, we have L minus 0 the whole square is equal to L square by 3. Here cos 0 is nothing but 1. So 1. On taking the constants as on left side, so L square minus L square by 3 on solving 2L square by 3 is nothing but this thing. Here 4 is again a constant, so leave that 4 left side. So on taking that 4, we just get an answer as L square by 6 is equal to summation this thing. They are asking us to find the value of the summation of this thing only. So, for this function of L minus x the whole square in that interval of 0 to 2L, we have the summation value as L square by 6. That's all for this sum. So, what we have done? We have solved this problem for 0 to 2 pi and for 0 to 2L. This is one part. Next thing, we are going to that function of minus pi to plus pi and minus L to plus L, the other section. For this section, first we have to know the simple functions, simple definition of odd and even function. What is odd, what is even? A function is said to be even if, this is our definition, f of minus x is f of x. Then if f of minus x takes the value of minus f of x, then it is said to be odd. It means on replacing our x by minus x, if the function takes the answer as a given function itself, if both are same, then we take it as an even. They are not even, but they are not equal. They are equal to minus times. It takes the value, but it takes minus 1 additionally. Then the function is said to be odd. For an even function, we have an example as x square, cos x, x sin x, etc. For odd function, we have the example as x cube, sin x, tan x cube, tan x, etc. These are some of the examples for even and odd function. Next, some of the simple notes. For an odd function, we know that minus pi to plus pi f of x takes the value as 0. If it was an even function, then this takes the value as 2 times 0 to pi. Okay, for an odd function, no need to find minus pi to plus pi. The integration will take the value as 0. For an even function, the given interval is split up into 2 times. 2 times of even ranges, 2 times of positive ranges. Minus pi to plus pi is split into 2 times 0 to pi. Similarly, for L, the same cases as for pi or L. Minus L to plus L takes 0 if it is an odd function. Same thing, if it is an even function, then it takes the value of 2 times the positive region. Note number 2. If the function is an even function, we have to calculate 2 terms, a0 and an. And that too begins 1 by pi minus pi to plus pi. It reduces to 2 by pi integral 0 to pi. And our an becomes 2 by pi 0 to pi f of x cos mx. And our bn becomes 0. Minus pi to plus pi f of x sin nx equal to 0. For an even function, calculate a0 and an. Okay, for that case, our Fourier's expansion is nothing but a0 by 2 an cos mx, in which a0 takes the value 2 by pi of f of x, an takes the value of 2 by pi into integral f of x into cos nx dx. Note number 3. Suppose it is an odd function, what we have to do? No need to find the value of a0 and an. Just go through only by bn. For that odd function, our Fourier series expansion is nothing but f of x is equal to summation n equal to 1 to infinity bn into sin nx. Okay, where bn takes the value of 2 by pi integral 0 to pi f of x into sin nx dx. Next, Since a naught and an 0, we are calculating and we are finding only bn alone. Where? For case of odd function. And one more thing. Even and odd function cases can be used only minus pi to plus pi or minus L to plus L. Whether the function is defined in those intervals, we have to check whether the given function is odd or even. For other function, for other in the sense for other intervals, that is in case of 0 to 2 pi or in case of 0 to 2L, no need to find, no need to check whether the function is odd or even. That's meaningless. We are going to split the interval into equal half, 2 times of positive, only where minus pi to plus pi or minus L to plus L. In the minus range to plus range, we are finding whether the function is odd or even. Okay. These are some examples. Cos nx is said to be an even function and x bar n is an odd function if n is odd. Same thing, x bar n is an even function if n is even. Okay. Once again, simple note. We know that the product of two even function is again an even function. And the next note is the product of two odd function is even function. We know that the product of two either odd or even, if both are same, then we get an answer as an even function. If both are even to, we get even. If both are odd, again we get an even function. Suppose one function is an even and another function is odd, then our net result is obtained as an odd function. Okay, if both are equal, we get an even. If one is odd and one is even, we get an odd function. Next thing. Suppose our f of x is defined in that interval, then at the point of discontinuity, that means at the point of minus pi or at x is equal to pi. In that case, the sum of the Fourier series can be obtained by adding f of plus pi plus f of minus pi by 2. The sum is obtained by taking the average value. For example, one simple question in that interval of minus L to plus L. Find the Fourier series expansion of periodic function which is defined in the given interval and deduce the value. Okay, first we just go through. The given function is in the range of minus L to plus L. What is our condition? We have to check whether the given function is odd or even. If it was even, we just calculate two values, a naught an alone. If it was odd, find bn alone. No need to waste our time by calculating another things. So in order to avoid those things, first we check whether the given function is odd or even. How to check? We have to find f of x and we have to find f of minus x. If both the values are same, even. Not same, then it is said to be minus same in the sense odd. So find f of x, the value is given function. Finding f of minus x. By replacing our x by minus x, first interval becomes L minus x, minus L less than or equal to minus x, 0. And L minus of minus x becomes plus x, 0 less than or equal to minus x, L. See here, what's our minus x? We have to multiply our x minus this side. So, on taking minus outside, we just get minus L greater than or equal to, less than or equal to x, less than or equal to 0. This becomes the first one. The second equation brings to the first place. By replacing our x, taking minus common outside, here becomes minus 0, meaning of 0. The inequality less than or equal to becomes a greater than or equal to, here x, here greater than or equal to L. So, minus L less than or equal to x, less than or equal to 0. Same thing for here too. If we take minus common outside, we get L greater than or equal to the same change of sign. So nothing but 0 less than x less than plus L by L minus x. We get an answer of this thing. This is same as our given equation. In that interval 0 to L, we get the answer as L minus x. Here too for 0 to L, we having an answer of L minus x. So, on substituting our x for minus x, we get the same answer of f of x. So, the given function is even. For even case, no need to find value for bn. It is enough to calculate value for a naught and en. On substituting a naught value and substituting an value by using the formula, we just find the Fourier series expansion. See, what's our a naught? A naught formula, as it is an even function, the formula for a naught is nothing but 2 by L 0 to L f of x dx. So 2 by L integral 0 to L, even function is in that range of 0 to L. Our function is nothing but L minus x. So put L minus x dx. So 2 by L on integrating L minus x, here power 1. So x power n on integrating x power n plus 1 by n plus 1. On integrating this, we get L minus x the whole power 2 by 2 into minus 1, which is nothing but minus 2. On substituting upper limit minus lower limit here. On substituting, we get an answer as L square by 2. On cancelling and find a value as a naught is equal to, we get it as a L. In the same way, we have to calculate our an value. Formula for an. An is nothing but 2 by L integral 0 to L f of x into cos n pi x by L into dx. On substituting f of x by the given function L minus x, we are having this thing. So we have to use our Bernoulli formula, u v, u dash v1, etc. Here L minus x is our u, cos n pi x by L, integral cos of this thing is nothing but our integral d. So on substituting u, on differentiating u and integrating v, we get the answer. L minus x u, on differentiating we get 0 minus 1, which is nothing but minus 1. U L minus x, u dash minus 1, then u double dash 0. So no need to put u double dash. 2 terms alone enough. As u and u dash is enough, we have to calculate up to v1. Here dv is nothing but cos n pi x by L. So v is nothing but L by n pi into sin n pi x by L. So v1 is nothing but 1 by n pi square cos n pi x by L. No need to find value for v2. Why? We are having value for second derivative of u alone. U dash alone we are having. No need of find the second derivative. So here too it is enough to calculate our v and v1. On substituting this in the Bernoulli formula, u v minus u dash v1. Before solving, just to find wherever we having a cos function or sin function. For sin function, no need to solve, as if we put our L getting cancelled, we get n pi. Sin of n pi takes the value of 0. Same way, cos of 0 again 0. So by substituting our upper limit and lower limit, we get an answer 0. So no need to find the value for first term. So our second term alone we are having. In order to solve this, first we have to find the symbol. Sign the symbol. Minus into minus plus. Plus into minus minus. So put a minus. 2 by L. In the remaining L square by n pi. Then cos n pi x by L. L 0. On solving this, upper limit minus lower limit. L getting cancelled, we have cos n pi minus cos 0. We know cos n pi. Cos n pi takes the value of minus 1 power n. According to our n, the value should change. If it was cos pi, then the value is minus 1. For cos 2 pi, we have the value as plus 1. So here they have given only alone n pi. So we have to represent that terms in terms of n. So the formula is cos n pi takes the value of minus 1 power n. Minus 1. So on solving this, 2L by n square pi square, and inserting our minus instead, we just replace as a 1 minus of minus 1 power n. This is our an value. Go and substitute those things in the given function. Thus the Fourier series expansion is f of x is equal to a naught by 2. We have a value of a naught as L. So L by 2 plus summation an value into this thing. Now we have to find the deduction part of this thing. In order to find the deduction part, we have to substitute. For first we need, in terms of cos, we have to eliminate the trigonometric function by substituting our x value. So what we have to substitute? If we substitute for x equal to pi, it need not, they will give pi square. So by substituting x equal to 0 alone, we just eliminate our cos function. So in order to eliminate the trigonometric function, substitute x equal to 0 in the equation. Here x equal to 0 is nothing but our discontinuous point. For the discontinuous points we have discussed already in our previous slides. For x equal to 0, the limit of the function can be calculated as f of 0 plus f of 0 minus by 2, which is nothing but here put x equal to 0. So L plus 0 plus L minus 0 by 2. Nothing but 2L by 2, which is nothing but L. So by substituting x equal to 0, our f of x takes the value as L. So L is equal to L by 2 plus summation of this value. Again, bring the L by 2 left side. So L minus L by 2 takes is equal to this thing. Here too, we have L by 2 equal to, take the constant left side. Here the constant terms are apart from n, we have to take all those terms. So pi square by 2L is equal to summation of this thing. We are having this thing alone, 1 power n. So on solving this, we get pi square, L and L getting cancelled by 4. So pi square by 4 is equal to this thing. Okay, we have to substitute n value. First substitute n equal to 1. By substituting n equal to 1 in this equation, we have pi square by 4 here, the first term 1 by 1 square into 1 minus 1 power 1. Then 1 minus 1, see here, 1 minus of minus plus 1, which is nothing but 1 plus 1, 2. 2 by 1 square. Okay, this is for 1. Suppose it takes n equal to 2. What will come? 1 by 2 square. Okay. 1 minus of minus 1 part 2. Minus 1 part 2. On squaring minus 1, we just get the answer as 1. So 1 minus 1, 0. So 0. On substituting 1, we get the answer as 2 by 2, 1 square. On substituting 2, we get the answer as 0. On substituting 3, the same way, we will get an answer. So we get pi square by 4 left side equal to, on substituting 1, we have 1 by 1 square. On substituting 2, we get 0. On substituting 3, we get 2 by 3 square. Similarly, on substituting 4, we get 0. On substituting 5, we get 2 by 5 square plus etc. This is our answer for substituting n equal to 1, 2, 3 in the previous equation. Okay. Here is there anything common? Yes. In the numerator, 2 is common for all the terms. So take the 2 common and bring it to one side. So it becomes taking 2 and taking 2 this side, becomes 4 into 2 is nothing but 8. So it will become pi square by 8, which is nothing but 1 by 1 square, 1 by 3 square, 1 by 5 square, etc. So on solving for n equal to 1, 2 and 3, we get the answer as pi square by 8 is equal to this question. The same thing formula, same like minus L to plus L, we have to solve the problem for minus pi to plus pi. In those cases too, what we have to do? In case of minus L to plus L and minus pi to plus pi, we have to check whether the given function is odd or even. If it was odd function, find Bn alone. In this sum contains an even function. So we calculated A0 and An alone. Find the value for even means A0 and An alone and substitute, and then find the summation value. Okay, this is our problems. Okay, these problems should help you for your exams. Just go through it, and by using the same concept, try some of the problems in your book and exercises. Thank you.